Exciting, fascinating world of chemistry. Today we're beginning to look at bonds and specifically chemical bonds. Definition of chemical bonds. They are processes of combining two or more elements chemically, and there are two types of chemical bonds. As we discussed last year, they're either going to be ionic or covalent. Now, we're going to look at covalent later. Definition of covalent bonding is bonding due to sharing of electron pairs. And when we work with this, we're always looking at a non-metal to non-metal bond. All right. So, ionics, we are going to look at this definition of ionic bonding. Bonding due to charge caused by electron transfer. This is a metal to non-metal bond. And the way that we represent it is there's something called Lewis dot diagrams. It means representing ionic bonding. Now, we did this last year. Let's do a quick review, Na and Cl. So if we go look at the valence electrons, I have 1 valence electrons for sodium. I have 7 valence electrons for chlorine. Okay, now, if I want to get the most stable state, I'm going to lose that 1 electron. So I have Na with no dots. I'll lose electron. The charge is positive. Chlorine is most stable as an octet as well. So we put 8 electrons around the outside shell. That gives us negatives. The charge is opposite in sign but equal magnitude. So the formula here is NaCl. We'll do ALF together in class. Now, we are also going to look at something called, this is going to be a little different, lattice energy. Lattice energy is the energy to form an ionic structure. To do this, we're going to convert ionic crystals into vapors of each ion. We're going to use Appendix E and pages 260, ionization energies on page 266, electron affinity on page 271, and Appendix E. So for the Appendix E, that is a formation reactions. So for sodium chloride, Na solid plus 1/2 Cl gas goes to NaCl solid. We need that one. We're also going to need the energy to convert Na to a solid to Na of a gas, and that's also in Appendix C. Then I need to convert Cl2 of a gas into Cl of a gas. That's also in Appendix C. So we got all in the gas forms. Then we need the ionization energies. Na of a gas is going to go to Na plus of a gas. That's going to be the electron affinity. And that's found on page, ionization is on page 266. And the last one we'll need is Cl of a gas plus 1 electron. It's going to go to Cl of a gas negative. That's on page 271. So what we're going to use these all together to do the lattice energy. First thing we'll do is take the formation reaction, flip it. So NaCl of a solid is going to go to Na of a solid plus 1/2 Cl2 of a gas. And if we go back in appendix, we see that over here, it was negative 410.9 kilojoules per mole. The other values here, sodium is 107.7 kilojoules per mole. The chlorine is 121.7 kilojoules per mole. The ionization energy rather is 496 kilojoules per mole, and the electron affinity there is negative 349. So again, if we flip it, instead of being negative 410, it's positive 410.9, and then taking Na of a solid to Na of a gas. You see that is 107.7. It still is 107.7. All right. Then we want to take and ionize it. So we take Na of a gas plus, not plus, is going to go to Na of a gas ion plus 1 electron, and that is 496 kilojoules per mole. Okay, so at this point, my Na cell is gone, my Na of a gas is gone, we got an ion, that's what we want. All right, so then we go back over my chlorine, using that value, 1/2 Cl2 is going to Cl of a gas, and that is 121.7 kilojoules per mole. And then lastly, the electron affinity, taking Cl of a gas plus 1 electron gives me Cl negative of a gas, and that's 349 kilojoules per mole. All right, so we go through there. My Cl is gone, my Cl of a gas is gone, my 1 electron is gone. In my end then, I have, and this is the process of lattice energy, solid, that's an S, going to Na of a gas to a charge plus Cl negative of a gas. We add this up and we don't work sig figs. Answer's 787.3 units here, kilojoules per mole. All right, we'll also do this one in class together. Take 2 pages. All right, we'll do these in class together, so copy those down. So make sure we know the terms, the process, and the problems. That's it. Take care, be good, have a good day.